Welcome to AEL. We are going to learn how to interface a 16x2 LCD with Arduino from start to finish. So, what exactly is a 16x2 LCD? It's a small, low-cost display that can show up to 16 characters per line and has 2 lines. It's fantastic for giving your creations a way to communicate with you, whether it's showing sensor readings, status updates, or even simple menus. We'll be using an Arduino Uno 16x2 LCD display. 1K ohm potentiometer, which is important for adjusting the contrast of your LCD, making sure the text is clear and readable. LED, which can be any color to act as an indicator, showing us the state of our button. Push button to interact with the LCD and demonstrate how to read input. Now, let's connect everything up. Note that pins with the same labeling are connected together like the connection from our LCD to the Arduino. The RS register select pin on the LCD goes to Arduino digital pin 2. The enable pin goes to Arduino digital pin 3. The data pins D4, D5, D6, and D7 on the LCD connect to Arduino digital pins 4, 5, 6, and 7 respectively. We are using a 4-bit mode here to save on Arduino pins. And for our indicator LED, connect it to Arduino digital pin 13 through a 220 ohm resistor, and its short leg, cathode, to ground. For the push button, connect one leg to ground through a pull-down resistor and the other leg to Arduino digital pin 0. The LCD is powered by 5 volts. Also, the VSS pin on the LCD is connected to ground. The VEE pin is for contrast and is connected to the middle pin of the 1K potentiometer. The other 2 pins of the potentiometer go to 5 volts and ground respectively. Connect the RW data pin 0 to pin 3 to the ground to prevent them from floating. With connection done, it's time for the code. I'll be walking you through the provided sketch. Let's break this down line by line. Include LiquidCrystal.h. This first line tells the Arduino to include the LiquidCrystal library, which simplifies all the complex commands needed to control the LCD. The numbers in the parentheses, 2, 3, 4, 5, 6, 7, are the Arduino pins we connected to the LCD's RS, enable, D4, D5, D6, and D7 pins, in that exact order. Next, we define our pin assignments for the button and LED. We also declare variables to hold our button states. Inside void setup, we set our button pin as an input and our LED pin as an output. Initialize the LCD with its dimensions, 16 columns and 2 rows. LCD.print, welcome to AEL, is an optional welcome message that will briefly appear when the Arduino starts up. Now for the void loop. We initialize the initial button state to 0. New button state reads the current state of our push button. Remember, digital read will return either high if the button is pressed and low when it is not pressed. We then have an if-else statement. If initial button state is the same as new button state, meaning the button is not pressed, we turn the LED off. Otherwise, if the button state has changed, meaning the button is pressed, we turn the LED on. Inside both conditions, we use LCD set cursor to position our text at the first column and first row. Before you can compile and upload this code, you need to make sure you have the LiquidCrystal library installed. Most Arduino IDEs come with it pre-installed. Let us compile and take the hex file to our simulation. There are two ways to do it. First is by compiling and copying the hex file. Second, by exporting compiled binary, then go to the folder you save your work and upload. If you find difficulties doing it, then don't worry, because I made a video showing how to do it step by step titled Simulation with Amiga 328p. Once uploaded, click the simulation button. You should see "Welcome to AEL" briefly appear, then the LCD will start displaying button state like 0 indicates that the button is not pressed. Our LED should also be off. Now, go ahead and press the push button. You should see the LED light up, and the number on the LCD should change from 0 to 1, indicating that the button is now pressed. Release it, and it goes back to 0 and the LED turns off. You've successfully made your Arduino and LCD communicate. And there you have it. In this tutorial, we've gone from understanding what a 16x2 LCD is, to wiring it up with an Arduino, uploading code, and seeing it display real-time information from a push button. If you found this video helpful, don't forget to subscribe to AEL for more exciting electronics tutorials, and hit that notification bell so you don't miss out on our next adventure. Thanks for watching, and I'll catch you in the next video.